Hello everyone, and welcome back to physics. Today we are going to be looking at how to find the magnitude and direction of a vector when you have been given the vector components or the unit vectors. When we're looking for the magnitude, the formula that we're going to use actually is derived from the Pythagorean theorem. And the formula is written like this. The magnitude of your vector is equal to the square root of your I vector squared plus your j vector squared. Now, these two lines here on either side of the vector, that means magnitude. So whenever you see these two lines, it means that we're looking for the magnitude. When we're finding the direction, we're going to use the TOA from SOHCAHTOA. So in other words, we're going to be using tan to find our angle. Now, when we're looking at our direction, we have to identify the quadrant that our vector is in. Now remember, quadrants start like this. This is quadrant 1. This is quadrant 2. Quadrant 3, and quadrant 4. Remember, we use Roman numerals for these. So, in order to find out which quadrant your vector is in, you need to look at the signs of your vector components or from your unit vector notation. And the signs are written like this. In quadrant 1, you will have positive I and positive j vectors. In quadrant 2, you'll actually have a negative I vector and a positive j vector. In quadrant 3, both your I and j are going to be negative. And for quadrant 4, your I is positive and your j is negative. So once you determined which quadrant your vector is in, you are going to use this following formula. Tan of theta is equal to your j vector divided by your I vector. And you don't have to worry about any negatives in here. You can just put it in as normal. So this is the formula that you would use to find your angle. Now, this angle is not necessarily going to be your direction. You may have to adjust things depending on the quadrant you are in. That's why we have this here. This just gives us the angle with respect to the horizontal. And you'll see what I mean in a couple of minutes when I do an example. So let's get right to that. Let's go over the steps before we jump into an example here. Step 1 is optional, but I highly encourage you to draw a picture because it can help you figure out the stuff in regards to the angle and the direction. Very important for that. Step number 2 would be finding the magnitude using this formula right here. Step number 3 would be finding your angle from the horizontal, which uses this formula right here. And then step number 4 would be finding the direction based on the quadrant that you are in. So let's go ahead and do an example. Given this force vector of negative 10I plus 23j newtons, we want to find the magnitude and direction of this vector. So, step 1, let's draw a picture. Draw a picture right here. I'm going to draw my quadrants. And I'm going to draw in my vectors. So I'm going to say that my I vector is going to be in yellow. So negative 10 on the I, that means it's negative going to the left. So this is negative 10I. And I'm gonna draw this in red, my j vector. So starting from here, I go up because it's positive. So this is 23j. So my final vector is in quadrant 2. And I know that my direction that I want to have eventually is this direction right here. So let's find our magnitude. So magnitude of my force vector is equal to negative 10I squared. But I actually don't need to put in the I. So I just need to put in my value there. So negative 10 squared plus 23 squared negative 10 squared is 100, and 23 squared, if I put that into my calculator, is 529. Then I'm going to add those two up. I will get a total of 629. And when I take the square root of that, I end up with a magnitude of 25.1 newtons. So my magnitude, I'm going to write that in purple here, 25.1 newtons. I'm just going to go ahead and make some space here. Now I'm going to find my angle. So I'm going to use tan theta is equal to my j, which is 23, divided by my I, which is 10. And I don't need to put the negative in. So 23 divided by 10 gives me 2.3. To find my angle, I have to do tan negative 1 of 2.3. And when I put that into my calculator, I should get an angle of 66.5 degrees. Now, this angle right here, this is the angle inside here. I don't want that angle. I want this angle in here. So this is where I have to find the direction based on my quadrant. I'm at step 4 now. So because this is in quadrant 2, I'm going to take 180 degrees minus this angle in here to get the remaining angle here. So 66.5. And that would give me 113.5 degrees. So my direction is 113.5 degrees. And that is my answer right there. All right, I want you to try it now yourself. Find the magnitude and direction of vector v that has negative 3.7i minus 6.8j meters per second. Pause the video here, take a minute, work it out yourself, and then you'll come back for the solution. All right, so our first step in the solution would be to draw a picture. So let's draw a little picture here. Again, I'm going to color code. I'm going to say that my I is purple. It is negative, so it's going to be going this way. And then I'm going to say that my J is a dark blue, and it is negative, so it's going down. This means that my vector right here, it's in quadrant 3. So let's do step 2, finding the magnitude. take the square root, negative 3.7 squared plus negative 6.8 squared, all under the square root. I should end up with, let me do this calculation really quick, 13.69 plus 46.24. When I add that up together, I get a total of 59.93. And then finally, to get the square root of that, I end up with 7.7 meters per second. So this is my magnitude. Next, I'm going to go to step 3. I'm going to find my angle. So tan of theta is equal to my j, 6.8, divided by my I, which is 3.7. So 6.8 divided by 3.7 gives me 1.838 approximately. To get my theta, I do tan of negative 1, the inverse tan of 1.838. And I get an angle of 61.5 degrees. Finally, I need to find my total angle, my direction. So I only have this angle in here. I need to find the total angle right there. So I look at the quadrant I'm in, and I'm in quadrant 3. So I know that the full angle of this line here, of the x-axis, is 180, and I have this additional angle in here. So I'm going to do 180 plus my 61.5 to get my direction of 241.5 degrees. And then I'll write it out. Magnitude is 7.7 meters per second, and my direction is 241.5 degrees. Thank you for listening, and I'll see you next time.